All right, good afternoon, everyone. My name is Thomas Haver, and thank you for coming to the Automation Firehose, Be Strategic and Tactical. So I made this a themed presentation with the help of my team and others. So you've got a lot of locally sourced, artisanal, hand-drawn images included in this. So if the content isn't fitting for you, at least you'll have some nice images to take with you. So this is in a comic book style. So today we're going to talk about overall automation from an organizational level, as well as within a given team, some of the sort of trials and tribulations. This is not me coming sort of from the mountaintop with 10 commandments saying, this is what you should do for automation. I think it's more of like a 12-step program of, this is where we've made mistakes, and we need to atone for those and say, we can do better. And so in that process, I'm going to take you through a bit of the origin story for automation of the tools that are used and the approaches that we've had, as well as what you need to consider both from an organizational level, planning level, as well as on a team. And then I've phrased this cleverly, the challenges. Sometimes we've heard them as opportunities, things where we've gone wrong and ways in which we can improve and address this. So a little bit about myself. So I work for Huntington National Bank as a senior application architect. I lead our enterprise automation team. I was previously a research scientist for about a decade before I went into IT. I'm also a huge board gamer. I own around 2,000 board games, and I travel around the world to play a game called Diplomacy. For those of you who don't know, Diplomacy is a game of negotiation where you can say anything to the other players and nothing's holding you to your word. It is known as the destroyer of friendships, hence the reason why I have to travel around the world to play Diplomacy. I'm also an evangelist for Ruby Cucumber. So a lot of the examples you'll see within this is Ruby Cucumber. That's not saying it's better than others, it's just sort of my own personal preference. And I also have a cartoon family to go along with that, a wife and 2 lovely kids. So let's get right into it and talk a little bit about the background for the automation tools that we have. And I want to do this by saying, I mentioned in the title, be strategic and tactical. And I think it's important to define those from the outset, whereas with strategy, we're talking about sort of an overarching plan that you're going to have, an approach to addressing a problem, whereas tactics are what you're actually going to do to achieve that goal. So Star-Lord's in here as an example. So we've all likely seen the Infinity War movie, where his strategy for defeating Thanos was sound, and it was going to work, but his emotional tactics cost his team the snap, and he lost. We have to sort of take that same approach with automation, is that we have to have a sound organizational strategy, and when we actually implement it, we have to be consistent and really take that hard look at ourselves, both from a perspective of are we generating return on investment and the metrics that we're going to measure. I snapped away my presenter tool. Here we go. So the first place that we want to actually look at is a trip back in time for Microsoft. So some of you may be familiar with Alan Page of Microsoft fame. He wrote How We Test at Microsoft. So he was responsible for test excellence. Microsoft has a tremendous challenge when they are testing. So this is taken from 2004 for testing upgrades that you're going to make to Windows OS as well as IE at that time, IE5 and IE6. This is the scope of their testing. Anytime they have to make updates or go through a patching event, you multiply this by 26 different languages that they have to support, and you eventually reach an impossible task of you cannot possibly test everything and make sure it's good. For them, the solution that they came up with is to establish personas of putting together buckets of sites, of companies that they support, of user bases to try to test everything as best they could. This is an example of why we sort of need automation in place of if we're going to be testing the same things over and over again across these numerous combinations, then it just makes sense to have something in place that can support us. The promise of automation has always been that, hey, we're going to end up saving you a lot of money, we're going to reduce the amount of time that we have to do this, and we're going to increase quality. That's been the promise, and I think it's really been overpromised time and time again, especially from vendors selling tools or people like myself saying, hey, we need an enterprise automation program. And really, it started with, say, you could say QTP, which eventually became UFT. A lot of the tools from the outset that we were using were very UI-based, focused on brittle tests that if an element moves on, say, a web page or a desktop application, then the test would break. You would have tests that would break that would lead to test reports that have a lot of failures, and suddenly the confidence is reduced. And it doesn't matter whether you're using, in this case, say, Ruby Cucumber, or you're using PyTest, or any other sort of heavy automation tool where you're requiring to have coding knowledge, or you move into the realm where we're going now, which is RPA, robot process automation, where you have less coding that is required, and you have more sort of user interface as a tool that will help you get there, to even the point at which we're going to adopt AI machine learning. That's, most of you have likely heard AI machine learning as sort of buzzwords, whether it's test.im or test AI, that we're gonna adopt this. And oftentimes it's sold as like, here's your silver bullet tool that's gonna solve everything for you. And it never meets expectations. So, let's not only lower those expectations, but understand where we can actually generate that value. So this is one where I typically have audience interaction, but I cannot see you because of the spotlight, and we've got people in other rooms. So instead, I will give a little bit of background. When I've given this talk a few times, and some of the common challenges that people have are in the maintenance of their automation, of flaky tests that they constantly have to go back and fix, and stakeholders that don't actually look at the reports. They care that, is it passing? Green good, red bad, as a very simplified version of this. They don't really invest the time to have automation be part of their life cycle. It's considered an afterthought, something that occurs after the development code is done and not something that runs concurrently. And so this all leads to challenges. It reduces the confidence in our automation. It makes it sort of a secondary concern, similar to QA overall. Most of you have probably experienced a time where development is done and it takes a little bit longer to complete, and QA's time is cut and it's done afterwards. So we end up taking a very strong risk-based approach, and it happens the same way with automation. Or instead, if we're working in an agile environment, the work is considered done when the developers are done. And then we recycle and use those same stories in another sprint and say, hey, now the testers have to work. So these are some of the challenges that we have associated with automation we need to address on an organizational level, that sort of strategy. So this is what automation is supposed to help with. So over the course of time, when we're building out an application or maintaining a legacy application, it becomes more difficult for us to maintain the coverage that we need to. So quality ends up dropping over that course of time, whereas the development costs go up. And if we implement a good automation solution, then it's supposed to reduce the amount of time that we need to actually test, expand our test coverage, and improve application quality. This is the promise of automation. So let's make sure that we can at least deliver on that promise. So let's talk about what makes a good strategy from an organizational standpoint. So one is scope. You need to understand where automation fits within the picture of, is it something that's going to be done strictly for end user behavior? Are you going to test components, say integration tests? Are you going to integrate quality and make sure that's an upfront concern for developers in terms of unit tests? That's what we care about. We care about what objectives, something that we can actually measure. Not just that we have automation and we're executing it, but how things are going. We care about the approach that we're going to take with the individuals involved in the organization. How is it going to change the SDLC? What sort of technical skill set is going to be needed for the people to actually write that automation? As well as an organization, what framework and tools are we going to use? Are we going to go with commercial off-the-shelf software, or are we going to develop an internal solution? So these are the things that we care about overarching as a strategy of how we can integrate in the SDLC, how we can make sure that this is something robust and mature automation, whether it's we started automation at a certain time before and it failed and we want to reboot it, or we're doing it for the first time. So let's talk about the approach that you'd want to take with automation. What I advise from a strategic level, from an organizational level, is to develop a sort of checklist that you would use for automation feasibility. We want to reduce the variance that occurs, team to team or even individuals within teams making a determination of, yes, this is something that would make a good automated check versus, no, it's not a good candidate, we should test this quote unquote manually. And it could just be a series of questions where just checking it yes or no. Or you could put in place a rating system to determine, hey, is this something that's actually feasible? So these are the sampling of sort of questions that you would ask of, can we actually automate this? The reason why you want to put this in place is to reduce that variability that occurs between people or between teams. You want to be consistent across the board in your approach, because otherwise you end up having, between multiple applications, different set of standards that they're following and completely different looking, say, automation suites as well as levels of automation implementation. So you don't want to get into any sort of mischief. You also need to, upfront, take into consideration the costs of automation. Not just simply, hey, we've bought this commercial tool, it's $10,000 per license or $2,000 per license, or we use open source and it costs this much for us to use the IDE. You need to consider that automation should have the same sort of upfront concerns that you would invest for development code. That every line of code that you write for automation or every script that you create through one of those tools has to be maintained once you write it. That's why it's important to very carefully choose what you're actually going to automate. So it's important as an upfront concern that when we're automating, we have to take into consideration what are we going to do in terms of upgrading our framework, upgrading the languages, upgrading the OS, creating that documentation that we're going to have, onboarding our people, making sure that it's integrated into the SDLC, whether you're using CI tools like Jenkins or Bamboo to help execute this. How are you going to handle the reporting and metrics that are generated by this? So all of this is in addition to the initial cost, the investment that you're going to make with automation. And all of this should be considered when you're looking overall at the time investment you've made of, we're saying automation is saving us stuff, but if we have to constantly update our suite, or we have to constantly maintain our framework, or we have 10 teams and they each have their own framework, and it's very difficult for people to go between teams or us to share scripts. These are all maintenance costs that we associate with automation. So when you are selecting tooling and determining the approach, it's important that you take this into consideration for what it matters from an organizational level. We all have organizational constraints, whether we're working for a startup or a Fortune 500 company. And it's important to take that into consideration when you're determining your strategic approach. Those things such as, what is our project delivery time, like our lead time that we have associated with automation? What is our constraints in terms of project budget? The individuals that we have within the organization. Are we going to have an expectation that the automation code is going to live with the development code in terms of our acceptance criteria, or are we going to be more flexible about what we're going to do? The organizational constraints will often dictate what tool you're going to use, as well as how far you can take the test automation. In some cases, you're not going to really have value placed upon even unit or integration tests because the delivery timelines are going to restrict people. And that's often the first thing that ends up being cut. So we need to demonstrate as an upfront from an organizational level the costs associated with us declining to use the sort of end-to-end functional automated tests, the integration tests, and the unit tests. And overall, as an organization, say, all right, here is what we are losing by not using appropriate automation for those three levels. And based upon that cost, which should be large, this is what we can work with in terms of our program to help save us money, to actually meet those expectations for automation. So when I talk about automation, it's important that we level set, not just with ourselves, but with the management that we have to deal with. These are our stakeholders who are funding us. It's important to note that this automation is not a replacement for all testing activities. It is not to say, hey, we're getting rid of manual testers or getting rid of manual testing. Testing as an activity, exploratory testing, performance testing, load testing is valuable. Your automation that you're running is not going to replace that. It's supposed to enhance it. It is supposed to be used as a tool that will help testers do their job. It's important that the automation that you have in place should also be consistent, be valuable, something that is reviewed by people, that helps reduce that uncertainty in your work. That is one sort of definition of testing or testing activities, is that you're trying to reduce the uncertainty that you would have in the product or project that you're trying to deliver. Automation should assist with that. If instead, when you are implementing automation, you're making sure that you're executing and you have flaky tests that are running, or you have environmental and data concerns, and people stop caring about the actual automation, they're just not reviewing the results, then great, you've invested all that time and money and no one is looking at it. So it's important that we set these parameters as our good test automation. So framework and tools, I mentioned that this is an important component in terms of what you select. And really the first sort of branch that you take is the difference between whether you're going to use open source or you're going to use some vendor tool, commercial off-the-shelf software. So the most popular is obviously us doing web testing and web testing with Selenium. So this is just an example, and a lot of the examples I'll show you will be a sort of Selenium, Ruby, Cucumber. But it doesn't mean that that's the best. It really matters based upon those organizational constraints that I talked about. It could be that your organization is more equipped to adopt some sort of vendor tool, UiPath, Blue Prism, Tosca. If you're nationwiders, you're all going to love Tosca soon. And using these vendor tools because maybe you don't have people that have the coding background for it and you don't want to invest in training them for it, or you want to have something that provides that formalized support. That's always a risk. If you're going to use open source, then the community support is a big concern about that. That's why I think, at least for web testing, Selenium is strong, because you have support across multiple languages. It is a heavily used tool, so when you do have issues, it's often addressed by the community, by those open source contributors. So this gives you flexibility, because if you can do so, then you want to try to align the automation language with the development language that you're supporting. If it's all possible to have both live within the same place, then absolutely do so. But automation is not just about web automation. You have to support likely desktop, API services, mainframe, mobile. And so in the support, in your tool selection, you may end up with multiple tools. At my company, we do support multiple tools from the automation standpoint, from both the sort of like the custom ground up built Ruby Cucumber to Test Complete from SmartBear to Blue Prism. So we have a suite of tools that are used, and each one sort of has its own focus area. And that's really what you need to do from an organization to determine how much are you going to actually put in terms of not only financing, but what makes sense in each area that you want to support. So when you're actually going to implement it, whether you're using one of these outside tools or building from the ground up, it's important that you try to make things as reusable as possible. The more time that you spend scripting and putting in place work underneath the covers in your framework and upkeep is a reduction in time that you'd spent in actual testing activities. So the example that I provide here is we're reusing these steps again and again in a very imperative style. So for those of you who aren't familiar, on the top level, this is Gherkin, a given when then format for a domain-specific language. It's a way to make things business readable for all members of the team as a way to collaborate. But going strictly with what's shown here, a very imperative style, as in we are UI heavy of how the user is interacting, is just one step in the process. Underneath, you can have a lot of rewritable code, reusable code, I should say, that you don't need to touch again. The user clicks something, hey, we've written that once, we're going to reuse that 1,000 times. But sticking to something that's very UI-driven that we have there is not the end point. So you end up having very long tests that you want to wrap up in a sort of declarative statements to describe the user behavior. And in some cases, Gherkin format user behavior is not what you want to describe, especially for some back-end processes where you're not talking about a user interacting with the system, you're talking just about the system, say, going through batch processes. In this case, you want to have that reusable automation, but not necessarily with that top level, because every time we invest on a different level of abstraction, that is more maintenance costs that we have to have associated. So what else can we talk about is important from an approach from an organizational level? So integration tests, absolutely. We need to, one, because they are faster than those sort of UI tests or end-to-end tests that we're expecting. They will help us in the actual SDLC, as in early on determining if there's a problem with a module or what we're going to actually connect together. This is something that is more focused in the developer space than, say, the traditional tester space for writing those integration tests. These are us connecting together those business rules. Unit tests are a must. I'm not going to show you the test pyramid. You've seen that to death, nor will I go through and show you a CI/CD diagram from Jez Humble. Unit tests run on the order of hundreds of seconds. They will allow us to pinpoint issues early on and very quickly. And there's a whole host of tools that we can use independent of whatever language you're using that will allow us to execute these tests very quickly, get good feedback, and within, say, our CI/CD pipeline, receive feedback, reject builds, so we don't actually break the application. So unit and integration tests are an absolute must. And so in this way, it's not just simply, I'm an automated tester, I'm a software development engineer in test. Quality is the responsibility for everyone within the team and really everyone within the organization. And it should be baked in to your expectation, your definition of done, or you finishing and moving out of the implementation phase of your waterfall, that you have unit test coverage, you have integration test coverage, and guess what? They pass. So that expectation is a must and an upfront, because that's where you're going to actually get the most bang for your buck in terms of automation. But we often encounter problems. I'm going to take you through this. A lot of folks here are in the automation space, and you will recognize some of these challenges. These are mistakes that I've made many, many times. My team has made many, many times, and we continue to do so, and we strive to get better. So this is us sort of addressing that. One of those is the automation Firehose, taken from the name of the talk, is whenever we're given a new tool, whether it's the commercial off-the-shelf software or it's our own tool that we're building, it's something shiny and new, and so we have the habit of wanting to use that on every single thing we could, automate everything. And if we do so, then great, we've now invested in the maintenance costs for that, as well as we may have done something that was not really valuable. Tests that are running that are not checking features that users are actually interacting with or don't provide much revenue for our company. So instead of automating everything, you need to make that judgment call of maybe you create a ranked listing based upon, should we automate this because it's a legal compliance risk, or because this is where a majority of our user base is interacting with the system, or the business decides that this is a very valuable feature. So it's important when you're automating to do so in a way that will generate the most value for your company. And not just automate everything, but automate strategically about what is important for an overall plan, and then tactically when you actually put it into place is something that is valuable, that is consistent, and that will allow the stakeholders to see that the state of our application is good. Another place where we have issues is we're going to write an automated check, and it's great, it works in, say, int, or works in QA, or whatever environment stage, but it doesn't work in any other environment. And that's because we're not building it to work across those environments, including the test data that's associated with it. So as an upfront concern, when we're deciding whether or not we should automate something, and before we even write that test, we need to make sure that we have control over our test data, that we can have appropriate levels of generation and manipulation. So that way, one, we're not just generating data and leaving it be so-called selfish data, but instead as an upfront that we can go across environments, we can generate all the data we need, we can do all the cleanup after we're done with our test. We don't want to leave a messy sort of house once we're done. We want to sweep up beforehand before we do our job, and we want to sweep up afterwards. So we want to be cross-environment compatible. That increases the value of our automation. If I'm able to write a single test and have it execute across 5 different environments, great, that's better than doing it 5 times manually. Or if I'm writing an automated check that only works in a single environment, it may not be something that we end up deciding to do. Even though it's feasible, it's something that we will not actually do because it doesn't provide the same value as we would across 5 environments. So what else? Well, the one that's most consistent with us that we see again and again are the so-called flickering tests or flaky tests. Is great, we get it done, and oftentimes we're under pressure for deadlines and meetings, and we decide it's good enough, and we push it out. I mean, there are tests that I wrote this year that were, hey, under deadlines and pressure that I regret. And that's because these are tests that are not consistent, they're not robust. So we've all encountered that. Instead, what I advise is take the same consideration. Since we're saying our automation code is the same as development code, that means that we have tech debt, the same as you would have tech debt for development code. Those flickering tests, every single one of that is tech debt. So you need to perform a failure analysis on that. Are those tests failing because the application itself is flaky? We have data or environmental concerns that are preventing us. Hey, you have a database refresh and you're stuck. You don't have the data. It's all wiped out that you're using. Or is it something to do with your automation script? We do occasionally make mistakes with our automation scripting. And we want to determine whether we should actually keep that test or not. If we're going to keep it, we want to update that to make sure that it runs consistently. Because nothing is worse than having us execute and provide the execution reports of tests and say that 50% of these failed, or 25% of them failed, and we have a variable number of failures on a day-to-day basis. Having all those failures means that that is time that people on the team have to invest in doing a failure analysis for it, and having that variable number of failures means that our stakeholders are going to stop trusting our actual execution. So it's actually better, instead of having those flaky tests, those flickering tests, for us to pull them out and make that something that's manual, then have it run and reduce the confidence in our test and take up time doing an investigation. So treat your flickering tests as technical debt. Within an example of a digression with Ruby Cucumber, they added in from 3.0 and above the ability for you to identify those so-called flaky tests that will show up and call it out explicitly, as well as a rerun feature that will allow you to rerun X number of times the test that you have. So at the very least, you can say, hey, upon multiple reruns, we did get a pass and the application is functioning appropriately, but we do have an issue with our automated checks. So another issue that we often encounter are those long tests. So we get in the habit of writing it and also writing in the imperative style, where we end up having 200 or 300 lines worth of those automated checks that take forever to finish. And some of the applications, that's by their very nature. So we support, say, mortgage loan origination. And that's a process that takes days to go through manually for an officer. And our automated checks are also things that are going to run and take hours to go through and simulate that end-to-end interaction. Those are important ones that we should be testing because that's ultimately what our end users are going to do. But the longer the tests, the more difficult it is for the stakeholders on the team to understand what exactly is going on, as well as the greater the likelihood for failure. So SauceCon just wrapped up a few days ago, so from Sauce Labs. So whether you're Browser Stack, Sauce Labs, Perfecto, or any other cloud-based solution, they look at what is the execution time for tests and what is the failure rate. At SauceCon, they did an analysis on all the tests that were running based upon failure rate and time to run. Tests that ran 7 minutes or longer failed at twice the rate of tests that finished in under 2 minutes. That, we consider, hey, that makes sense, right? So the longer the tests are, the more opportunities there are for you to have a failure point through the interaction, if you're especially going through the UI, of having issues with data UI or something that just breaks along the way that you're not exactly sure about. So we want to try to keep our tests as short as possible, one for readability, but two is to actually make it so the tests are executing consistently. And in some cases, for readability, it's easier to say wrap all of those imperatives up into declaratives. So describing hey, the user's end state, what goal they are, instead of describing I log into and navigate to an application, I enter my username, I enter my password, I hit login, I say no to the challenge questions, I say no to this offer, and finally on my account overview page, I can just say, hey, the user is on the account overview page. Those are the things that we want to describe that get to the point of what you're actually trying to accomplish. Another issue that we often face is a shaky foundation. We're so eager to start and show value that when we put in place an automation suite we build out, or we're working with a commercial tool and we just put together, hey, here's a flow that we have as an example. We're not making considerations for extensibility, where we know in the future we're going to have more projects, we're going to have more checks that we're going to have to add on, and also potentially we're going to have shared services to deal with. We're going to work with multiple application types and end-to-end flows that travel across multiple applications that we want to work with. So what should we do in this case? Well, we should treat it again like it's development code. Use the best practices that we consider within the community, using Dry, using KISS, making considerations up front of building a good framework that can be used for years across multiple platforms, across multiple projects, instead of writing those one-offs. So I've worked previously at a place where every single feature file that we wrote with a set of tests also had an associated step definition file, and so we ended up with hundreds of step definitions. That's a maintenance nightmare compared to 3-step definition files of 40-some steps that is consistent across all web applications. That is something that's easier to maintain. And modularizing your application types, so that way, if you're supporting something that is front end where it's web, back end you need to run some database tests, and maybe in the in-between you need to also have web services. You want to be able to snap those in place and make it easier for people to use rather than custom build every single solution. The more you make these reusable across multiple teams, the easier it is for your maintenance. So just keep that in mind. So another issue that we commonly face is when we're lagging behind development. So developers are done, and they say, hey, we are done, putting quotation marks, done. And then it gets thrown over the wall to the testers, or even the test automators. And now they have to write those scripts to interact with the UI or interact with the service layer. What is better is to develop the automated checks, concurrently with development. Look at it from the perspective of your actual developers. They say that they're done with a given story, and they switch their contexts. They go to work on the next story card, because they're not going to just sit there and wait for you to spend days to work on it. They'll say, hey, I'm done, I'm moving on to something else. But in the middle of them working on that next story, you have the tester come back to them, hey, I've got this problem with this, or I've got this question here. I don't quite understand, or you need to tell me about these checks, because I can't interact with this element. Switching those contexts is going to reduce their ability to actually deliver. And the more context you have to switch between, the less productive you are. So your automation should be upfront as part of your ready state criteria. Is this something that's feasible? Is this something we want to actually deliver? As well as part of your done criteria. The story is not done until you have those automated checks in place. So you should be writing your automated checks, your test cases, concurrently with developers so you can execute immediately and provide the developer feedback. And this is where it's also valuable if you can have your automated checks located in the same place as the development code so the developers can execute against it. We're not going to say, hey, every developer should, in addition to unit and integration tests, also write all those acceptance criteria, the functional tests that we have. That's not the expectation. The expectation is we try to do this concurrently so that way we can provide that fast feedback on what was actually developed, and the developers can stay focused on that story until we actually meet that true definition of done. So let's talk a little bit about how we can actually schedule this to go in place. How do we get the organization to shift and actually consider automation as an upfront concern? So one of those areas in which I recommend is the use of example mapping. So example mapping is about collaboration between those major roles in the team: developer, business analyst, tester, product owner, and discovery. So you're establishing a shared understanding of what needs to be done with that story or that feature. Formulating, here are the business rules that we're actually going to be implemented in the form of specifications. Here are our examples that we're going to use in the form of our test cases. And then the automation actually being written as a result of that. This is the 3-step process. And the form that it takes is those team members are engaged in an example mapping exercise. So this is part of your ready state criteria, where for each user story, in yellow here, you are going to capture the business rules as your acceptance criteria. Underneath each one of those business rules, you're going to have one or more examples that will highlight the actual implementation. In addition, for all of those members of the team who are in this example mapping session, they're going to identify questions. Anything that they can't actually answer in that room, they want to capture that and send that off to their stakeholders or other outside technical resources. Maybe you need to engage the architects, or you need to engage another team. You want to do this as an upfront concern. Why? Why should you use example mapping and apply it to automation? Well, the shared understanding is important, because this will allow us to actually figure out, all right, everyone on the team agrees what needs to be done and what are our expected user behaviors. So instead of, hey, the testers end up writing off their test cases and no one else on the team actually sees that, especially if you're writing plain language English on the top. You instead want to have everyone else engaged. And you want to provide this sort of toll gate that occurs that prevents work that is not really ready for the team to begin to skip it and say, no, until our questions are answered, we need to actually go back and rethink this. So what are the benefits of us using example mapping? Well, those examples become our actual test scenarios, our functional end-to-end scenarios. Those rules that we have written, those are our business logic that become ultimately either our unit or more likely our integration test that the developers are going to work on. Those questions are something the business analyst can take back and work with the product owner to address. So you've, as an upfront, said that we're going to have these test automation scenarios that will apply to every single business rule. So we have our test coverage in place. At least one test per business rule that we have. In addition to that, we know what the developer should do in terms of the business logic that needs to be implemented. So that shared understanding created on the team is very valuable. There's also some background that you can use based upon this when you're actually conducting these sessions that will lead you to conclusions such as too many red cards, too many questions means that work is not ready to begin on that story. We reject it. Too many rules associated with a given user story means that that user story is too dense. It's going to be too difficult to actually develop it in a time box that you have. So that means you need to break apart that user story into 2 or more pieces. If you have too many examples per business rule, that means your business logic that you've identified there is a little bit too dense. You need to tease that apart and break it into 2 or more business rules. So that's why the color coding is in place, is for you to quickly and visually identify, are we on the right track? Or what changes do we need to make so the team can actually complete this work? So here's an example map where it's about scheduling a workshop. So we say, hey, our goal is to schedule a workshop. What are some actual rules that we'd have in place? Well, we want to make sure that we can have a location where we host it, and some examples would be, hey, if we have too many people that are associated with it, we need a room. Otherwise, say we can meet in the atrium or lobby. We also want to make sure as a rule that it's occurring within normal business hours. Well, what's an example of normal business hours? Well, between 8 a.m. to 5 p.m. As well as other considerations of who actually needs to be there. Can we conduct this session when we don't have the full team participation associated with it? And some questions you may ask about it is, should catering be required? In my opinion, yes. Do you need a projector, or can this be conducted just simply face-to-face? So this is an example map. It only takes about 30 minutes to go through an example mapping session. So this is a good way for us to generate those scenario names in the form of those examples and the business logic that ends up becoming our integration test later. So what sort of standards are we going to put in place for automation? This is us from a high level going to the actual tactics now of we're conducting it on a day-to-day basis within the team. One of those ways in which I recommend the collaboration to occur is a regression review. So in a regression review, we want that test leader, whoever say is going to take on the responsibility for all those test cases for a given project or feature you're developing, to gather all those test cases to share with the other stakeholders on the team. We want to also get information from whoever's working on our production support about where our incidents are located, where are we having trouble within our application. As well as we want to get information from our business partners. What are our users doing with our application? Like, where are they actually interacting with it? What is providing the most revenue from our application? And from that information, the team will get together and make a determination of what should be part of our application's core regression. Where are we having gaps for our automated checks? Where are we having gaps for our testing period? This establishes that shared understanding amongst not just the members of the team, but members of the organization about how you should actually execute your automation and where you have gaps in your automation. To help make automation more robust, you should also be conducting code reviews and refactoring. I know I've said this multiple times, but we need to consider our automation code the same way as we would development code. Here I've got Martin Fowler here as a superhero. He's a superhero to me. In code reviews and refactoring, we want to make sure as an upfront, before we are done with a story, that the automation code has been code reviewed, that other members of the team or organization have gone through and made sure that we're not developing brand new functionality that's a duplication of other functionality that's been used somewhere else within the organization, that the automated check that we've written will actually consistently execute. We don't want those flaky tests anymore. That everyone on the team has an understanding of what checks are we actually executing here and what is going to be something that's going to be a manual test. So code reviews for test automation should apply the same as we expect code reviews for development code. We should also be conducting refactoring sessions on a consistent basis, team to team. Why refactoring? Well, we're not changing, by definition, the underlying code itself. We're just making it more easily maintainable, extensible, and we're sharing that domain knowledge. We have a habit, if we're working on a given team or a given project, to sort of have that laser focus just on that given feature, and we sort of miss what else is going on within our team and within the organization. Even if we have things like a daily stand-up to provide that update, we end up ultimately missing out on what others are doing. We want to share that domain knowledge. When we conduct a refactoring session, we want it to be something that is regular, and we want it to be something where we are focused on making sure we don't have that duplication, that we make sure that anything that is outdated or not useful is removed, that we identify areas where we can improve not just the suite, but as an organization. So that non-orthogonal design, so the underlying code, not just the over-top automation, the scripts and steps we have. To make this something that is regular, my advice is to have those regular refactoring sessions where you identify one person as that team leader. That is the person that's going to schedule the meeting, who's going to choose a focus area for it, and is going to lead it. You also want to have someone available with a good technical background from the automation space to assist the team. Those people are going to be there to just simply help out anytime that you encounter obstacles within that refactoring session. In addition, you want to choose a given focus area. And it could be varied. It could be, hey, here's a given product backlog item I'm working on, or we're diving into our regression, or this is what our CI report has generated, or a static code analysis report. So you have a given focus area each time you go in. So this spreads that domain knowledge. This helps us make sure our automated checks are healthy and our underlying suite is in a good state. So making this something as regular as a habit will prevent you from having decay within your automation. The last section is a bit of a challenge, talking about metrics. And that's because for most of us, metrics have been used as a cudgel rather than helpful behavior change. And the reason why it's been used as a cudgel is known as Goodhart's Law. Goodhart's Law states that as soon as you attach a target to a metric, it ceases to be a metric. Targets such as, well, 25% of all of our defects should be caught by automation. Why? What makes 25% good or 20% bad or 100% great? You don't want to attach the target, because then what ends up happening is people will alter their behavior just simply to meet the target, not address any sort of underlying concern. Think about in terms of, hey, we want to have a good percentage of automation. We care about having 50% of all of our test cases automated. Well, it's very easy for people to break apart the test cases and make them very granular, so that way you have a higher percentage of automation. Our metrics that we use should instead be helpful in changing our behavior and understanding where are we going as an organization and what can we do to help address that, not individually to point fingers. So percent automation is one that's commonly used. What I care more about is effective automation, and that is to say, for the test cases that we've identified as feasible and ones that we should automate, that we actually automated those. Because certain test cases are ones that aren't going to be good candidates. I don't care about whether we really count those or not. What I care about is what we could possibly do. Are we squeezing the most value from our automation out of that? What else do we care about? Well, our coverage. So if we break apart any given application we're supporting into regression, the core behavior, release, what new functionality we're delivering, as well as our smoke test or our sanity test or critical functionality that's run, say, by prod support, we want to take a look to see, all right, what is the amount of time and what is the coverage and execution frequency that we had? As in, are we able to execute our regression more frequently with automation? You should, as well as release, because you have that limitation, that investment up front where you are going to develop the automation in a given environment and hopefully test in future environments. And it's not necessarily guaranteed, if the application behavior has changed, that some of your regression tests will be maintained, as in functionality will change, or it's something you should just completely get rid of. Tracking for your automation, what the scope is in terms of your coverage is important. For what we have as a total application, like looking at it in terms of how much testing are we actually doing. So one of those numbers you can generate is simply our automation tests run twice a day for our regression that takes 10 hours for them to execute that otherwise someone would have to. And so that's 20 hours every single day that we're saving time with. So another place that we want to look at is if we're going to use, say, example mapping, or if not, you capture the business rules in some common repository, QCALM, Jira, whatever. You want to make sure to have good coverage of your business rules, your acceptance criteria. This is not to say your individual test cases, but the business logic that your stakeholders care about. Do we have automation coverage for that business logic? In addition to that, we want to be able to check at our savings that we have for defects. So as a general statement, defect costs go up when you actually get to production. In every environment you move up, the defect costs increase, the cost of that rework. So we want to, as a promise of automation, find those defects sooner, have testing activities find them sooner, where the earliest we can find it is in the requirements phase, which most automation cannot unless you're, say, using some machine learning for it. Well, you end up generating a matrix where on one end of that, you're looking at what are the phases of our life cycle, and on another, of what is the criticality that we've determined of those defects that we found. From that matrix, you can generate costs associated with, hey, this is a critical, and when we reach production, it costs us, say, $10,000 to actually fix this. This is low priority that we found in QA. It costs us $1,500. Generating this matrix and then associating not just our automation, but our overall testing activities will help us to generate numbers to show, all right, this is where we're getting savings. This is where we have gaps in terms of functionality. So that way we can invest the right amount of time so as not to completely eclipse the amount of savings we find from defects. Defect coverage is another important component of this. We want to make sure that we are actually having coverage over our defects, whether the automation caught it or not. If it's something where after the fact we've determined that we can have an automated test because there's a defect here, it may not have met the criteria up front, but after it's a defect and the business cares about it, we want to have coverage, because nothing is more embarrassing than having a defect crop up again and again and reach production again and again. Like, that's something that represents sort of an organizational challenge where you have a failure. For the automation side, we should at least have defect coverage of everything that we've discovered that's possible. So that way we can make sure that, hey, reducing that uncertainty, the automation is in a good state of testing that application. So having defect coverage is important. So the other way is that defect trend. So if we're going to mature our automation, then we should be able to track those defects found in by phase. That means that the automation should find the defects earlier in the life cycle, the so-called shift left in quality. Well, we should be able to track that number of defects we found relative to that project size and what phase we found it in. And we want to track that project by project, year over year for each application. So we should see that shift in left. If we're starting to see shifting right, we want to understand why. Is it because this is an overly complicated project? Is it because we lapsed in our standards? Or for some other reason, maybe it wasn't a good candidate. We don't have even the capabilities to write those automated checks. And the last one is one that I care about tracking, is the so-called time savings. And I hate to toss up like equations like this for you, but this is useful, at least in providing the value to the upper management, is we want to take a look at what does it take for us to actually test an application purely manually against the number of events, against the number of environments, and against the number of user combinations, against the difference of once we've implemented automation. This is not to say it's 100% automation, but we've implemented automation. How much time then does it take us to execute those same activities? So the difference between the two will provide you that time savings of manual minus the automated implementation, multiply the number of counts, like, hey, we have to have regression testing bare minimum 8 times per year, multiplied by we need to go do it against 3 environments, multiplied by the number of user combinations. We've got 20 browser OS device combinations. So this can provide you that information about how much time you actually save by having automation. Now, does that mean the upper management would have invested in adding in X number of people to do the testing if we didn't have automation? Most of the time, no, right? They're going to assume risk. All sort of testing activities are risk-based. But at least in here, we can say, this gives us the opportunity to do something we otherwise would not have done and would have taken us this much time. So there are a lot of other metrics that I could go through with this, but I'm going to save you that. So those are things that you can look at and say implementing automated software testing or lessons learned from automated software or just enough testing that are in the resources section of my deck. So in summary, we can make consideration for what is important as a takeaway for good test automation. We want to focus on unit tests as the upfront, followed by integration, followed by those functional UI tests, and then lastly, those very long end-to-end tests, because that will provide you the most bang for your buck, focusing on unit integration up front. We want to also make sure to automate strategically. We want to have, as an organization, consideration of what are the complex scenarios, what are the scenarios that require the most data or environment intense or legal compliance that we want to address. And we want to automate those ones that provide us the sort of greatest risk. And lastly, it's important for us to take into consideration that automation is a maintenance cost, that we're investing it the same as the development code. And for us to be effective with automation, we need to automate both strategically and tactically, from an organization level down to the individual who's writing those tests. So thank you very much for your time. I appreciate it. So I'm available for any questions right now because we have a few minutes left on there.
I got a question from Slack here. How do you capture things like business rule coverage and defect coverage?
All right, so for capturing, say, business rule coverage, one of those examples that I had in there was example mapping. So those blue cards are the business rules. Those are ones you can capture. If you're not conducting example mapping, those are going to be the requirements that you want to try to capture in whatever tracking tool you have, and make sure that you have your test cases associated with that. In terms of defect coverage, you should have a statement of record that is going to track those defects, whether it's QC ALM, TFS, or JIRA. So you can track all the defects and see which ones are automated. And JIRA and TFS, you can update and add fields that will indicate whether it's automated or not. For QC ALM, you're going to have to do a little bit more work in identifying within that actual defect field. Mm-hmm.
Another question. Do you have any examples on how you have achieved any of these things? Even generalized examples?
Yeah. It's a broad question to go into some of those individual ones. That's what I've actually pulled out of this deck for the sake of having the Avengers show up on there. So I can go through a few of, we track the metrics for the teams that we support and the ones that I've listed there in terms of what are the number of test cases we have, what is our coverage there, broken down by test case and individual validations. We conduct with certain teams regression review as well as refactoring and code review sessions. And my team supports 73 applications, so it varies because certain segments do business differently than others. And so if they want that information, like more direct with examples, I can provide sanitized if they want to reach out to me. And so that way they can see, hey, this is what we've actually done, where we failed, where we succeeded. All right. If you want my presentation, I'm going to provide it online. That's available through the StirTrek app, as well as if you want just separate materials from me, you can feel free. I'll pass you my business card and send it off. Thank you very much for your time. Mm-hmm.